Okay, last module, last body system in physiology is the respiratory system. It's not a super long set of notes. It's got some heavy vocabulary, but you can totally do it. So let's just start with making sure that you review enough of the anatomy that you know what a bronchial is, what an alveolus is, what the pulmonary circuit is. Make sure you know that before you start. And then let's just start with a little bit of terminology and a figure to get you started on the terminology. When we're looking through what happens as far as respiration, we have to use some terminology really specifically. And I actually used this wrong for a long time. So the processes are called external respiration and internal respiration. External respiration has a bunch of little sub parts to it. And the internal respiration is actually cellular respiration. So, external respiration is basically supplying the gases for internal respiration. And this is kind of the driver of the whole thing. So let's talk about external respiration and just break it down into parts, and then we'll go into the parts as we go through this set of notes. So first thing that has to happen with external respiration is what we call pulmonary ventilation, which is just a fancy word for breathing. Air in, air out, okay? Not specific gases, just all atmospheric air in and all atmospheric air out. Eventually, our body will pull some specific gases in and get rid of some specific gases, but that's not what ventilation is. Then, after we've got air in and out, which is occurring right here, right? Air moving in and out, then we are going to do gas exchange twice. Gas exchange at the pulmonary capillaries is gas exchange between the alveoli, which have the air, the atmospheric air, right? And then the pulmonary capillary beds, which have the blood that is returning from the heart after like systemic circulation. Gas exchange is going to go on at the lungs and at the systemic capillaries via diffusion. No fancy mechanisms, no secondary active transport or anything like that. And then, of course, after you've done gas exchange here, and you see gas exchange as you're going through these capillaries indicated by the change in color, and the change in color is to indicate when you pick up oxygen versus when you drop it off, and you're used to looking at that red blood and blue blood, even though no, it's not red and blue. What will actually happen is now the blood is, of course, delivered back to the left atrium of the heart, with me. And then we are going to circulate that blood and the gases in it through systemic circulation. And through systemic circulation, we are going to deliver that high oxygen, low carbon dioxide blood through systemic capillary beds. And why are we going to do that? Because, of course, these cells need oxygen for cellular respiration and generate carbon dioxide via cellular respiration, bringing us all the way back to the beginning of the semester when, of course, we started with like metabolism, right? So now we are going to deliver that blood back to the heart and then start the whole damn thing over again. Now, all of this is fancy pumps and tubes and pressure generating devices, all to serve this, which is, of course, internal respiration, or the term you're more familiar with about it is cellular respiration. So all of this collectively is external respiration to serve this, which is cellular respiration. Got it? Okay, so what we will do is we'll go through pulmonary ventilation, right, which is what we're going to do right here. And then we'll go through each of the other steps. Gas exchange, pulmonary capillary beds, gas transport, and then we won't do cellular respiration because you did it at the beginning of the semester and you don't want to do it again, and neither do I. So now let's start with the concepts of ventilation, or pulmonary ventilation, and lung mechanics. Let's start with those concepts. So I'm going to do this in more detail in just a second, but basically what happens is if you take gases in a container, let's say my thoracic cavity is a container, and you squish the gases, that actually increases the pressure. Good. Take gases in a container and squish them, and it increases the pressure. Got it? But if you take the same container and you stretch it, it decreases the pressure. So the way that inspiration and expiration work is that I'm going to treat this as a container. And it can be closed if I close my mouth, or it can be open, okay? But what I can do in this container is I can change the size, and I can change the size primarily based on the activity of my muscles of ventilation. And those muscles are primarily the external intercostals and the diaphragm are involved every time. And then sometimes you get your buddies, the internal intercostals, involved. Okay, so basically here is how inspiration works, and then we'll get into it in more detail. What I want to do is I want to increase the size of this container, the volume of this container, to decrease the pressure. And then the air, the atmosphere, is at a relatively constant pressure. If I decrease the pressure in this container below atmospheric pressure, then air will move in, because air moves like fluids do from high pressure to low pressure. Okay, so basically what I do to increase the size of the container is I contract the diaphragm, that makes it bigger, and then I pull out the external intercostal muscles. Okay, so with inspiration, I am going to pull out the external intercostal muscles and move the diaphragm down. The diaphragm contracts. Okay, so that increase in the size of the thoracic cavity causes a decreased air pressure, and then air moves in. That, of course, depends on your lungs actually sort of moving with the thoracic cavity. That concept we'll get to in a minute. It's called lung compliance. Healthy lungs are nice and stretchy and will move with the thoracic cavity. Expiration, just to give you an intro to expiration, really all it is squishing the container a little bit so that the pressure increases. And as soon as the pressure increases above atmospheric pressure, then air moves out. Okay. So because air, again, moves from high pressure to low pressure. And all you do to make that happen is relax the diaphragm. That decreases the size of the thoracic cavity. And usually it's just relaxing the external intercostal muscles. That's passive exhalation. And when you do that, air will move out. Normally, expiration is a passive process. If you are really physically active, or if you are voluntarily going, you can contract your internal intercostal muscles to squish the ribs together a little bit. Squish the ribs together a little bit. Stop. Stop, Soups. And you can also contract your abdominal muscles, and that will push up on your diaphragm a little bit from the bottom. That will squish the container a little bit more. And then you can do what's called forced exhalation or forced expiration. Okay, so now with that little intro, I'm going to get you guys started on the details of pulmonary ventilation in the next video.